The next one, we will take a look at how I set it up when I have this recycle stream. So this was the air conditioning, where we have some wet air entering. We want to dry the air, and we want to deliver 100 moles per hour to our customer or to our room. So we have one unit operation that just mixes a couple of streams. We have a unit operation that removes some water. And then we have a split where we basically take this stream and split it into two. These three streams all have the same concentrations. So we have to be careful of that when we are setting up our equations. But we're basically just gonna put that into Excel. I think I had it ready here as well. Yes. So we're gonna start by putting in the information. 96% dry air. Actually, because I only have two components, I can just do this all over the place. 96%, 97.7. Then I have my stream 2.1, 983. Stream 2.2 only contains water. Oh, I did it wrong. Hang on. 1 minus that one. There we go. There we go. So all of these I just calculate by taking 1 minus the other concentrations. 3.1 is 0.983, 0.983. That should check out. Total number of moles for all of these, no idea. I know I have 100 there, and I know I don't know what will be there. And finally, calculating the different component amounts. Fill right and down. There we go. And now I want to start to set up the different equations that is possible for this system. So I'm going to do it systematically and say I have for my total system unit 1, unit 2, unit 3. And for all of those, I could set up a total, a dry air, and a water balance. So let's look at our total system. So we're gonna put in our magical square, if I can remember where it is. There we go. So we're gonna put in our magical square and say if I'm only looking at the entire system, all I know is that stream 01 comes in, and that's stream 22. And, oh, let me do it like I normally do. Stream 22 and stream 31 exits. Okay, that would be my total balance. Then we look at our first unit operation. What do we know about this one? Well, I know that, where was it? I know that stream 01 goes into it. I also know that 3.2 goes back into it, and I know that stream 1.1 exits it. So stream 01 plus 3.2 minus 1.1. That's my balance for that one. We move to unit 2. What do we know about that? Well, in my unit 2, I know that stream 1.1 goes in. I know that stream 2.2, keep doing it wrong, stream 2.2 and 2.1 exit, and that's all I know about that. And for my final here, well, I know that, what is that, stream 2.1 goes into the system there, and stream 3.1 and 3.2 exited. Again, questions, just ask in chat. I'm trying to keep an eye on it. But I've now written all of the lovely mass balance equations that I can. I'm gonna fill them to the right. And now we start to get into where we have to decide what things do we want to remove, what equations do we want to remove. This time, because I've looked ahead a bit, I'm gonna remove my system balance. We're gonna remove our water balance here and say these are not independent of all of the others. That would normally be sufficient. However, for this, our unit operation 3, the concentration that goes in and the two that come out, the concentrations, the compositions are the same for all of them. So that means only one of these three equations are independent of all of the others. And you might say, hey, hang on, why is that? Why is it that suddenly we have to do it like that? So, come on. Where did my remarkable go? There it is. Oh no! I lost synchronization. What a horrible thing to happen. Let's do my quick sheets. And I want to share. There we go. Perfect. I will try to remember not to close it down again. So, why is it that when I have a system where I, for instance, just have this one, I have one stream coming in, and then two streams going out, and I have the same concentrations everywhere. So let's say we have XA, XB, and let's just to make it easy, let's say it's 60% and 40%, then A and B in the two others is also 60%, 40%, 60%, 40%. Stream 1, 2, 3. So why is it that suddenly I only have one independent equation? Well, what I can do is I can write up the equation or the total mass balance for this system. So the total mass balance for this system would just be stream 1 is equal to stream 2 plus stream 3. Okay? Now, if I then want to do my component A balance, well, all I have to do is take all of these and multiply them with the concentration of A, which in this case means I multiply everything by 0.6. So that means I'm taking one equation and just scaling it to a different size. That means it's not independent. It's like when I know in class I often say, well, if I have x plus y is equal to 10, and I ask you to solve it, many of you will say, well, we can't. We have two unknowns and only one equation. We need another equation. And I go, yeah, sure, I'll give you another equation. 2x plus 2y is equal to 20. And you go, no, that's not the type of equation we need, because this is just the first equation, everything multiplied by 2. So when the compositions in all of the streams are identical, then we have this issue that all of our mass balances are dependent on each other. We can only use one of them. So that's what we'll do in this case. We jump back to the Excel and we say, okay, I'm only using one of those. I can use those 4. So I have 5 equations. Let's hope 1, 2, 3, 4, 5 unknowns, exactly what I want. So again, data and solver, and just like we did before, I want this one to be 0. I want my other 4 equations here to have a value of 0, and I want Excel to change the values in all of the lovely yellow cells. Solve it. Excel found a solution. Everyone's happy. We just check. All of my values, all of my equations trend toward 0. All of my masses are positive. Looks reasonable. Yep, I have now solved another one where I have this recycle stream.